All right, we're going to look at all kinds of different words and terms that get used when describing problems around trigonometry. The first has to do with describing certain angles. So often they'll talk about the angle of elevation or the angle of depression. The way to think about elevate is looking upward. So think of this as upward. And the idea is usually that someone is standing along on a place and looking up at maybe the kite that's flying by or whatever. And the angle of elevation becomes this little angle down in this area here, because this is the angle looking up. Now the truth is students don't struggle with the angle of elevation at all. But basically, again, it's from the horizon, which is kind of that horizontal line, looking upward. And why students don't struggle with that, that's very natural. And also, there's a little angle positioned for that angle. Notice one thing, too, is that we're not doing this from the eye level of this person. To simplify the problem, we're doing it kind of from the foot, even though the angle would be from your eye, but we simplify it this way. Now, the angle of depression is much harder, and many students get this one wrong. The way it works is that you are up on top of something, looking down at something. Let's say we've got a car down here, and we're looking down at it. Now, why is this harder? Well, typically students want to tell me that the angle is this one right here. And I know exactly why they want me to tell me that, because I'm looking downward and that's where the angle is and so on. But that is not the angle of depression. The angle of depression is looking downward, yes, so it's still about being down. But it's down from the horizon, just as elevation is up from the horizon. Depression is down from the horizon. So the angle of depression actually is this angle right here. And so that's why it's a little harder, is because students think that this should be the angle, but indeed the angle of depression is this one right here. Pay attention to that idea. One thing, too, I would say to you that maybe you know from alternate interior angles, this angle of depression right here, if you want it in this triangle down here, which most do, you can move that down into this position. This angle of elevation from the car looking up to the boy or the girl is the same as the angle of depression. So this actually is an equivalent angle in here. And if you don't like having the angle out here, you can move it down here and then use this triangle. Let's practice with these two new words. This is always a favorite of mine because of the diagram. Let's check this out. We're looking for an angle of elevation from the boy. Here's our boy down here at A to the short brown building at D. So where is the angle of elevation? I think it's right in here. That would be angle 1. So let's say angle 1 is our angle of elevation there. All right, let's try the next one. We're looking for an angle of depression this time, and we're doing it from the top of the short two-colored building, E, that's right here, to the red car down here. Now, pay close attention. Angle of depression is looking down, so it's going to be from the horizon. Our answer is going to be angle 11 here, not angle 9, but angle 11. Let's take a look at our next one. We're now looking at the angle of elevation from the top of the blue building, that would be B, up to the airplane at C. The angle of elevation is looking upwards, so that would be angle 7 for that particular answer, looking upwards. All right, now we're back to an angle of depression from the airplane, so now we're up at C there. And we're looking to the top of the blue building. So we're looking right back at where we were at. Now, angle of depression, lots of angles going on there. I think that's going to be our angle 6, isn't it? Because that would be from the horizon, that horizon line, looking down. And so angle 6 would be our answer there. Not 5, not 10, but 6. next one. Angle of depression from the top of the brown building, that's G, looking down to E, the two colored one. An angle of depression is from the horizon looking down, and so that would be our angle number 12 is what that one would be. All right, the last one we'll look at to get this wording down is another angle of depression from the airplane C. Ooh, this is the tricky one, looking down to D. Now, let me mark this out with some nice clear markings here so we can see it. So here's the horizon line. Here is the guy we're looking at. Remember, it is from the horizon looking down. So in this case, it would be angle 6 and it would be angle 5 together. Now, we already have a name for those two angles. It's right there. It's called angle 10. So I'm not adding 6 and 5 to get 11 or something like that. There's a name for that. That's just angle 10 is the name for that particular guy. But it is that whole region there from horizon looking down. It's not 5, it's not 6, but it's the two of them together, which was called 10. Now, there are a lot of problems that use the same kind of environments. One of them is a ladder problem. So in a trig question, if they tell you what the ladder is, this, of course, is your ladder. This location here is where the ladder reaches the wall, is usually what they would say, where it reaches the wall. Another new term that you might not know is this down here would sometimes be called the foot of the ladder. And so that's the foot of the ladder. Now the two angles that get referred to will be this one here down in the bottom place by the foot of the ladder. And that one would be called the angle formed between the ground and the ladder is what that's called. Now in the upper spot, it would be this angle here, and it would be known as the angle formed between the ladder and the wall, or the wall. Another common place is something to do with a wire and a tree. This would be the wire along here. Sometimes this is called a guy wire. I'm not quite sure why, but it's called a guy wire. And what this wire does is it connects the tree to the ground so that it's safe and firm. So of course this is our ground, is how that would get referred to. This of course is with our tree and so on. And this is the brace or the wire. Now there are two angles here again. This one would be called the angle between the wire and the ground. And this one would be the angle between the tree and the wire. Be very careful about the notation that gets used there and what it's physically referring to. All right, let's tuck that away. Another common place is a kite flying situation. And when we fly kites, of course, this is always our string. And the string is tight and there's not lag in it, so it keeps it simple. Over here, of course, would be your height. And sometimes, sometimes it might be called altitude, but probably not, the height of the kite. And this is the ground distance, or how far the kite is in the ground distance would be kind of this length here. Now, this angle in the bottom left corner, you know what this is. This would be the angle of elevation looking up at the kite. We don't normally talk about the angle by the kite because there isn't really one there, kind of. Again, notice that she's not holding this string in her hand. She's got it tied to her big toe. And this would be the right triangle that we do. We simplify the triangle so that we can solve it. Another place might be looking up at something in the sky. It might be a helicopter in the sky. This boy is looking up at this. This is called the line of sight when you look up at something or look directly to it. That's your hypotenuse, of course. This would be the distance to the pad, right, to the helipad there. This might be called the altitude. Altitude is usually more in reference to like a plane or a helicopter a little higher, but it might also be the height. We might talk about the angle of elevation, the boy looking up at the helicopter, or in this case, we might have somebody in the helicopter looking down. Remember, if someone is looking down on us, they are going to use the angle of depression, which would be this angle right in here. And if you ever get an angle of depression, you have a couple of options. You could close out the big triangle here, or remember I told you that that angle would equal this angle. Altitude, distance, line of sight, angles of elevation and depression. Let's shrink that and put that away and bring up the last environment of terminology. This is often about the sun and its rays. The shadow that's cast by the boy's body would be on the ground, always is on the ground. This, of course, are the rays, the sun's rays, and this would be the boy's height, that would be here. And the angles, generally there's only one angle that ever gets talked about, is the angle formed between the rays and the ground, right, which would be this one. And then you're going to find something about the height or the length of the shadow or those kinds of things. All of these ones create right triangles that allow us to solve for things. I'm not going to solve these problems, but I'm going to try and draw them for us. 30 feet of string on his kite, angle of elevation at 27. How high is the kite? Let's make that. So here's a quick rendition of this. The string is 30. The angle of elevation is what I want to find. The height is here. And of course the next stage, which is the next guy we'll do, is how do we solve this? And so once we turn it into a triangle, let's solve it. This one talks about a ladder that's 20 feet long. It reaches a window that's 18 off the ground. What is the angle formed with the ladder and the ground? So here's our ladder that's 18 feet long. Here's the window that's 20 feet off the ground. Here is the angle of elevation, or in other words, the angle formed between the ladder and the ground. And then we would set up and solve the problem. In this question, they tell us a little bit about the wire being attached 4 feet above the ground to the tree. They want us to know what the wire is. And they tell us, notice where I put my 70, the angle formed between the wire and the tree is 70. Often students put 70 here, but it would be in this position, and then we would solve this right triangle. Let's draw this one live. We've got a helicopter over a landing pad. Here's the landing pad. And the helicopter is up here. Here's our little helicopter right here. Billy is out here somewhere, keeping an eye on it. It says Billy is 110 from the landing pad, so 110 is here. He looks up to see our helicopter. Looking up is an angle of elevation. So we're in this spot. And we find out that that's the 65, and it wants to know how high is the helicopter. So we would be solving for this height right here, or the altitude of the helicopter. Okay, similarly it says a man casts a shadow. So here's our sun up here. Maybe get out our yellow. There's the sun's rays coming down. Now the shadow is 3 feet long. That's on the ground. Sun's rays strike the ground at 62. What is the height of our man? So again, what you get here is a right triangle right here. The rays are our hypotenuse, 62 is that angle, 3 is here, find the height. This last one is the trickiest in that it has an angle of depression. It talks about a lighthouse, so let me create my lighthouse here. There's my lighthouse. And it's looking out at a ship at sea. All right, let's see what it says. From a lighthouse that's 30 feet tall, so this is 30 here, from here to here. And he spots out at sea a ship, and there's my ship. And he spots it at an angle of depression. Look what I'm about to do. I'm about to put a 10 in this spot. Too many students put it in the wrong spot. That 10 would go right in there because that's from the horizon down. And we want to find, how far we are from the lighthouse. This is kind of what we're trying to find, how far the boat is away. Now notice that that 10 is in that upper one, and so we can move it down here And now we can operate in this lower triangle. Angle here at 10. Height is 30. Let's find how far we are from the lighthouse.